All right, welcome back to Blueprint 101, Manufacturing 101. We're going to be continuing on with Section 2, Unit 2. We are now on page 70, which is ratios and proportions. Okay, so a ratio is a comparison between two numbers. Proportion is two ratios equal to each other. English metric conversions, we'll get to those here in a second, okay? So real quick, a good example of a ratio is 1 to 2. Also known as half, okay? So say we have a different ratio of 1 to 100. Basically it's 1/100th of a part, so one part out of 100 parts. A fraction, correct? Ratio of 1 to 50, one part out of 50. Okay? So again, we talked about fractions, sections, 2, 4 parts. Uh-oh. Now we're starting to get complicated, right? 1, 2, 3, 6 parts. And imagine they're all intersecting here in the center. Don't count these little pieces of my fabulous artwork, okay? Now I have 1, 2, 3, 4, 8 parts. So what we're saying here is we're 1 out of 50. So if there are 50 parts in this, okay? Let's give you another one just to show a scale. 1 to 8. 1/8. So we're one part, one ratio. Just so we understand, we're one part out of 8. Okay? Now what happens when we go the complete opposite direction? When our ratio is larger than this? When do we use a larger ratio in the beginning number? There's specific terms for all this. I'm not really concerned with all that. Again, this is not a math class. This is a blueprint course. There is a lot of math in there. Bear with me for 1 second. Okay, so 10 to 1. So on a typical blueprint, what we might see is a drawing that's going to tell us in the title block that it's 10 parts to 1. Okay? So, in this case, 10 inches is equal to 1. We're a whole number, correct? This might be when we have a very small part. And it's hard to see the details, and we don't want to draw it at a microscopic scale, because if we did it just 1 to 1, say this is a 10 millimeter piece, but we need to draw it to scale, because we would not be able to look at the fine print and detail within that little itty bitty section. So then basically what we're going to do is we are going to magnify it. Okay? So in this case we've got a 10 to 1 ratio, alright? And we can physically measure on the blueprint that this is 10 inches. So we measured at 10. We know in real life, this would be a 1-inch piece, okay? Let's break this part down. So, scale of 10 to 1 on our title block. We don't have any measurements, but we can actively measure this to a detailed drawing. So we lay out, we measure 10 inches, this measures 2 inches, and this measures 2 inches. Well, what about this side here? This, we know this dimension right here is 2 inches. So we've got 10 and we've got 3 to here. So now we can do basic subtraction, addition and subtraction. 10 minus 3, this section is now 7 inches. Okay? To give us a relative point, we can make a data line or a hidden line there for our point of reference. We would know that this is 2. This is 2, so overall we're at 4 inches. That is assuming we have this and this. So what do these two things right here mean? That means that they are right triangles. That means that they are at a true 90 degrees. Okay? So in that case, our piece here, or this line here, is perpendicular to this line. We will talk about parallelism and perpendicular here in a minute. Right now, let's focus on the ratio portion. Okay? So now, working backwards through this situation, we know that we are a 10-to-1 portion, or ratio. So looking at our math, get your calculators out, and we have 2 divided by 10 is 0.2. So in real life, 0.2 inches, 0.2 inches, 0.4 inches, so forth. Okay? It's important sometimes when we're working with small parts to be able to take the ratios and make them applicable to a real life part size. Real quick. Stay here. Next portion, or the next topic, is a proportion. The one they use in the book was very simple. So we have 60 miles per hour for 1 hour. Okay? So real quick, we know that how many minutes are in an hour? 60 minutes, 1 hour. Well, if we have 60 minutes and 60 miles, 1 hour, we now know that we are going 1 mile per 1 minute. Okay? That's what we call a proportion. All right, the next portion is going to be converting English to metric. So it gives us our scales that 1 inch is equal to 25.4 millimeters. Okay? So what we want to do is we want to figure out if we measure something that is 2.63 inches, how do we correct this? So 2.63 times 25.4, 66.802. We did it on a calculator. You can always do it on a long conversion. 2.63 times 25.4. Okay. Now let's go the opposite direction. We have a millimeters and we're going to convert it to inches. Well, we know what 1 inch is. 1 inch is 25.4. So how do we get here? I mean, we know it's 1, but then if we did just plain subtracted it, then we would have roughly, so this would be 9, 6, 1, 1, correct? 11.9. But still doesn't tell us. That means that we'd have 1 inch and 11.9 millimeters. There's a much simpler way to do this, by all means. And that's where I want to just kind of break it down for you. Very quick and simple. Just do direct division, especially if you have a calculator. 37.3 divided by 25.4, because this is an inch. It's the same thing. It's an inch. Okay? Ends up being, give me 1 second here. Get my calculator up here. So 37.3 divided by 25, divided by 25.4. 1.4685 inches. .4685 inches. So how does that measure out as far as if we're using a micrometer and we're going by thousandths or 10,000ths of an inch, then we're doing fine. However, how do we know what this is, fraction-wise? So now we're going to talk about just breaking down inches into fractions again. We talked about it. We're going to do a lot faster version in the top of our head. .0 is 1 inch. First of all, let's go right down, and I like to break it down in halves. Okay? I can do it different ways, but the simplest way for me to help explain it, teach it, is break it in half. So now we're at 0.500. 500's half of 1,000, correct? If you have a $100 bill, what's half of a $100 bill? 50 bucks. We know that. Okay. So let's break that down in half again. So we're down here on 1. Now we've done half. Now we're going to break the half into 2 parts. So we're at 1/4. So half of 50, $50, $25 or 0.250. Half of that again is now 1/8. So now we're at 0.125. Now let's break that down into half as well again. Okay? So we're at 0, 6, 2, 625. So just to double check, let's make sure. Let's do 625 times 2. 0. So we carry the 1. 4, 5, 12. What do we have? 1250. Okay? 1/32 would then be 0, 3, 1, 2, 5. Down into the 1/64th range. Okay? Break this in half again. 0.0. We know it's 1.5, so let's go start from the back here. We got 5. 25 goes into 50. Okay? 2 is 1. Sorry. Doesn't really work exactly the way I wanted it to on this. I want you to work through this on your own. You can look at 2.21, which was on page 69. So 0.015625. Okay. The more, as you can tell, the more decimal points you get, the harder it gets to be able to do just a simple breakdown in half. However, real quick, we are back to, let's fill in the rest of these variables. Okay? So quite simply, let's just start. We know 1/8 inch is 0.125. So 7/8 we're 1/8 inch off. So we take 1000 minus 125, we're at 0.875. 3/4, we're going to subtract 1/4 from 1 inch. So we're at 0.750. If you also notice, it's 0.25, 0.125. 5/8, we're taking an 1/8 off of this. And we can also add 1/8 to this, 0.625. 3/8, the same thing. It's right here in the center in between the two. So we got 0.375. Okay? So real quick, back over here on this equation, we had 1.468.5. 1.468.5. Okay? So we want to know what that's closest to. Well, we're less than 0.50. And we're higher than 3/8. So we know we're roughly in between here. Okay? So let's break this down even further. So I like to do addition. A lot of times subtraction's there, but the addition seems to be a lot easier for most people to understand. So 1 3/8, we're at 1.375. Okay? We need to add, so let's say we add 0.0625, which is 1/16 of an inch. Okay? Now we have 5, 7, 3, 1.4375. Okay? That's good. So to begin with, we had 1 3/8 right here. Let me put it here. Plus 1/16 puts it to that. Now we're still shy 31 thousandths. Looking over here, 1/32 is now 3125. So let's add 0.03125 to this. 5, 7, 8, 6, 4, 1. So if we were carrying it 3 places, we are exactly the same as above. So in this case, we added 1/32. Okay? So we need to find the common denominator again, correct? So let's take our problem back up top. We have 3/8, 1/16, and 1/32. To get to 30 seconds, we multiply times 2, 2 30-seconds, multiply times 4, 12. So we have 12 plus 2 plus 1. 14, 15, 30 seconds. So the closest under this is 1 and 15 30-seconds. Now we can definitely break down further and further, but as you can tell at this point, we're in the, here's the thousandths, now we're into the 10,000ths range. And this is going to be very, very critical. This would be like a bearing fit to the 10,000ths or so forth. Most of what we're dealing with is going to be in the 1,000th range, so this would be very close. Okay? So if that needed a drill bit in 37.33 millimeters, we could come over here and we could find a drill bit that is 1 and 15 30-seconds of an inch, and that would be very close to this. Okay? All right.